Oh, hey guys, what's up? Eddie Aho here with KissAnalog.com. Alright guys, we have this big old isolation transformer right here. It's a 2500 kVA. They rate them in VAs because volts times amps is watts, right? But you don't know what the power factor is going to look like. So you can only handle so much current, so much voltage. If they're in phase, lined up, then it's 2500 watts. But if they're not, then you can handle so much current, so many volts. So they give you in VA ratings, okay? Anyway, this guy is interesting because it has these power cables. By the way, I've taken these plates off. You can see that one just popped off. So I've taken these plates off to take a look inside. And yeah, there's some concerns. I want to, before I go to the trouble to rebuild this, I want to test it to make sure it's okay. So we're going to take a HiPot meter and we're going to HiPot the windings to the core, make sure, and the primary to secondary. We're going to make sure we still have isolation between those two things and from those two things to the core. So if the windings gotten overheated, it might be already burnt to the core or it might be close. And so the HiPot meter should catch that, okay? So we'll do that. But yeah, I thought it was interesting. Somebody just quickly put this thing together because they put power cords to these knockouts, but then they didn't put the little protector things on there so the cords fit properly, so they could get rubbed on the edge, and that's not a good thing. So whenever you see something where somebody did something like that, that's why I took the caps off before I put any voltage on this thing or did any kind of testing, because I want to look at it and see what they've done inside. It looks like they're in a hurry, and they probably has an application for this thing. They hooked it up and used it, and then I think I bought it in a surplus flea market thing years ago, and I always meant to put it on a bench, hook a bunch of stuff up to it because it's big enough to power a whole bunch of things. 2500 kVA, 2500 watts, that's a lot, right? So it does have the hookup for 20 amp. I only have 15 out here, which I could run everything I'm doing back here off of this bad boy. So that might be kind of nice. Isolate myself from the grid, give me some clean, it's a big inductor, right? So it's going to help clean up some of the noise that's out there on the grid for all this stuff, right? So maybe it's a good application for that. But it's an ultra isolation transformer. Has 0.001 picofarad of capacitance between primary and secondary. I mean, that's almost like saying zero, right? It's a topaz. Here, I'll show you what the end plates look like. We're going to look at the windings and we're going to HiPot it, okay? And then if it looks worth it, if these cords are reusable, I'll use them. But anyway, I'll wire it up properly. So yeah, there you go. Let's come over and take a closer look at this thing. Alright guys, so I've got the one end plate off, and you can see, let me get this cord out of the way if I can. You can see that it says X1 over here, X2 here, X3 there, so this is X1, X2, X3. Kind of smells funny, and X4. So I'm a little worried about it, but you know what? As I can see down in here, it looks clean. The windings, the tape on them, I don't see any burn marks. It looks all clean, but look at this cord. This black one is just crumbling and falling apart. Look at the insulation that came out of it. So the black lead definitely has been heated up and it's just crumbling. Now, the other thing is the green wire does go right to the chassis, which it should, but it's also tied into what looks like the neutral. But then again, I don't know what this is because it's just a wire that goes down into the transformer. Yeah, so I'm not sure what this whole thing. Now, this could have a screen on the transformer. That's likely what that is. It's a single winding going. So what they do is when they wind the primary and then the secondary, they put a screen in between them. That helps cut that capacitance down. And it looks like it's tied to the ground on this side, which is also tied to this winding, because there's four windings. I mean, there's four winding terminations here, right? And X1 and X2 is where this is wired. So it looks like, you know, it's curious because I don't see a wiring diagram on this plate, right? But what I would suspect is this is wired for I think this is, okay, I'm tilting the transformer so I can see this better, but ultra isolation, 2.5 kVA, 50 to 60 hertz. Let's see this 12240. That 12240 makes me think there's two primary windings. So if we had 120 like we do, I would think the two windings should be in parallel. So they didn't parallel the windings for some reason. Maybe they weren't using that much current, but then at the same time, this black wire, now the green and the white wire seem okay, but the black wire definitely seems like it's been charred. Now, I don't know if it's up inside the cord that way too. We'll have to cut open the cord maybe to see inside the cord. But definitely right here it's charred. So it's really curious. It's almost like if the neutral was to short to, and the, you know, if the inside the windings was to short to ground or chassis, then all the current would go through the black into the chassis. It'd probably be shared between the neutral and ground, going back to the power cord or pop the breaker maybe. I'm not sure, but that makes me curious. Makes me worried about this transformer. And then 240, you'd put them in series. But anyway, 120, they should have been in parallel, but they definitely not done that way. So that makes me worried. All right, guys, looking this closer, I take the cord, and I was trying to look at the other conductors closer, and what I see is the insulation on the green wire here. It looks like it was cut or nicked whenever they stripped off this wire. So I'm kind of wondering if these things shorted together up here. And so, but I don't know why it would have fried it down in here unless, yeah, I'm not sure. But yeah, it could be the current just all stayed right up in this area. But yeah, that looks definitely frayed right there. So I'm gonna split this open, take a closer look inside there. That could be that the black one heated up and the insulation on these burned off. I'm not sure. Okay, guys, so the concern's growing. On this side, same thing. The insulation on the black one's all charred, flaking off. Terminals all look great. This white wire looks good, but look, I mean, this thing was designed, I mean, the way it was put in there, you could just pull and stretch this thing, which, that is not good. That is not a good installation. The green wire goes to chassis again. Again, it looks like there's probably another screen built into this thing. So that's probably how they got the capacitance so low. They put a screen on both the primary and the secondary. So pretty amazing. And so we have this white wire tying the screen to the chassis. So any capacitive coupling between the two screens would get shorted to the chassis. And yeah, that would help your capacitive coupling from primary to secondary. Looking down in here again, the tape, everything looks super clean. I mean, that's what gives me hope for this thing, is that it does look nice and clean inside there. So I do have, you know, it is giving me some kind of hope that maybe things are going to be okay. But it's hard to explain this. Now again, they didn't parallel these plates, the output, and guess what, guys? On this one, that was the external part of the plate, and this is the internal. And look at that, we have a schematic diagram. All right, so this schematic diagram is showing H's. So the terminals we were just looking at are the input, the H pins, okay? So H1 and H2 is where things look like they're hooked up. Here, I didn't really point that out, but there's H1 right there. So H3 and H2. So H1 and H2 is where we're wired. H4 is where the screen looks like. So H3 and H4 are not wired. They are from the transformer, but not over here. So, but H4 is used for the screen, it looks like, and ground. All right, so when we look at this, H1 and H2 were used. And H4, yep, see S1, that's a screen. Oh, there we go, perfect. We've got the diagram. S1 screen, S2 is a screen, and they're tied to the X4 and H4, which, perfect. That's exactly the way they're done. Okay, fine. But the curious thing is why they didn't parallel the windings to, because if they were trying to get a lot of current to this that it's rated for, 2500, then they would have needed to put these windings in parallel. Or if it's 240 in series, you'd have to use all the windings to get the full power rating. So if you're only trying to get half, then you're okay. So yeah, I'm no worried about this. It looked like a really super nice transformer. Now I'm kind of worried. All right, guys, so what we're going to do is, first of all, we're going to check to make sure that each winding is still a winding, that it hasn't been opened because it was burned open or something from some kind of fault. So we'll ohm H1, H2, make sure that winding is still intact. Same with H3 and H4, and X1 and X2, and X3 and X4. So we'll make sure that the windings are actually still there, and that the ohms look like, like they should. They all should have essentially around the same ohms, right? So it's a 1-to-1 transformer, so they all should have the same turns. Now, the only ones that were connected was H1, H2 for the input and X1, X2 for the output. So for some reason they didn't parallel these. Being in the States, since we're 120, you just parallel them. If it was 220 or 240, then you'd put them in series, but they weren't. These guys weren't connected at all. Now, we also have these screens, and they're tied to one of the windings, and then that also gets tied to chassis. So that's kind of an interesting thing. We might want to tie the screens just to the chassis and not to the windings, because we don't want our winding tied to chassis, right? Because if chassis is the third prong, the ground, the safety ground, then we don't want to bond. If this, say, turns out to be line and neutral, we don't want neutral bonded to that. So we would want to open that. And maybe somebody had a wiring problem, and that's what caused the black wires to be charred. But let's check them out and see what we got. After that, what we'll do is we'll HiPot. We'll make sure that each winding is open from the other ones. There's no continuity between the windings. Now, of course, these two will, because if they're tied to chassis, then we'll have these two windings both tied to chassis. Okay, so in that case, those guys will be connected, but we shouldn't have any other kind of connections. And we'll probably have to remove the screens just to make sure these guys are all open. Let's do it. All right, guys, so what I'm going to do is use this meter right up here, okay? And so that way you can see it, and I'll just call out. So what I'm going to do is first, we're going to do a HiPot, but I thought, man, as bad as this looks, I'm just going to ohm it and see what we see. So I'm going from hot H1 to H2, okay? It's kind of jumping all over the place, isn't it? Now, it could be the cord itself. Maybe the cord has a short internal because of heating up. That's a good chance. So I need to take the cord off. But that is pretty low ohms for a big old transformer. And also the fact it's jumping around. That's weird. Okay, I'm going to go to the other windings, H3, H4, that we're not using. Okay, it's kind of the same then. That jump around might be me. Okay, I'm going to go back to the other one. H1, H2. Yeah, that jump around is probably me. Okay, so then obviously the screen is type chassis. That's pretty low ohms, 0.06. So, okay, just in case you had a hard time reading that, I'm going to call it out. So H1, H2, we're down like 0.24, 0.21, ohms. And H2 to H4, the parallel winding, I would think. Okay. Okay, 0.2, kind of similar thing. I think that, I think it's the way I'm stabbing these terminals that makes it jump around. Yeah, it depends if I hit the screw or the little tab. So it's just me touching in different places on this thing. So, okay, so those look equivalent at least. I'm going to go ahead and remove the power cord because I'm kind of wondering if the power cord, we're reading the power cord, or are we reading the windings in the transformer? Since they were the same, I think it was the windings, but okay. So it's disconnected now. So I'm going to go back to H1, H2. Okay, well, it's not jumping around so much, so maybe it wasn't just me. It might have been the cord moving around while I'm doing it, but still about the same reading, 0.22. So H3, H4. All right, so yeah, H3, H4 is about the same. Here, let me flip this thing over. Seems heavy. Oh, man. That's a beast. Okay, is that on camera still? Yeah, you kind of see the top, so you kind of see me probing around at least. Oh, you know what? And this power cord's messed up too, so who knows? Maybe we're reading power cords. Okay, so let me go to across the power cord, X1, X2. Very similar reading. It's a 1-to-1, so it has the same amount of windings on both sides, so that would make sense. Yeah, I was just trying to see if I can. There's a little dimple that I was trying to hit, and it seems like I get more solid readings. Okay, now we're going to X3, X4. Yep, and that looks pretty solid too. Okay, so now I'm going to go ahead and remove the power cord from here as well. I'm not taking the white one off because I'm just taking the black and, well, I'm taking the black and neutral, but not the ground's also that white wire, right? So I'm leaving that on there. But let's go ahead and take that reading now that both power cords are not connected other than the ground. Again, more solid once the power cord's gone. Okay, that was 0.17 or whatever. Okay, about 0.2 something, 0.22. Go back to the X1, X3. That was X3, I have to hit these things just right to get a good reading. Yeah, about 0.22. I don't know. They're both low, so it's looking promising. Okay. Okay, now that I disconnected both power cords, I can't ohm from power cord to power cord. So now I have to go to the terminals of the transformer from primary to secondary. All right, guys, so now we have our KPS meter. Really like this meter. And I've got these probes with these alligator clips, and I think they're just long enough to go to terminals on each side. And if you can hear that, a little beep, we should hear that. Okay, I'm going to go to H1 on this side. So that's one of the windings, right? And then if I go to the winding on this side, X1, it should, it doesn't really matter. I can go to any one. Okay, so the ohm meter says fine. The ohm meter says fine. OL, okay? So I'm going to leave this one over here, and I'm just going to go to all the terminals over here just to show, like, an ohm setting. Okay, here's the next winding, H3. Fine. Go to H2, which we already did H1, so H1 and H2 are the same, right? And then go to H4, just to be sure. And then as far as chassis, I'm connected to chassis now, but you know what? Before I do that, I'm going to leave this on H1, Okay, so that's the one of the windings on this side. And then we're going to go to all the windings on the other side. All right, so first of all, I just moved it to the other pin of the same winding. So, of course, that should be good. But just to, make sure. All right, guys, I'm touching X3, which is the next winding. So, yeah, both, as far as this ohm meter goes. Okay, and just to cover them all, I went to X4, okay? All right, so, of course, the screen should, the chassis on both sides should be connected. So I hooked it up to the screen on this side. Let's do the one on this guy. And then, yeah, 0.1, yeah, 0.0, it's working on it, 0 ohms. That's pretty cool. It kind of, whoa, yeah, my battery's dying on this guy. Time to swap out the battery. Okay, we're done with it anyway. Okay, we got to bring the HiPot meter now. Okay, guys, so I like to use an ohm meter before I go to the HiPot, the installation test. And that's just, because if it passes the ohm, then great. If it fails the ohm, there's no sense in running high voltage on things, right? So I've got this on the high voltage terminal out and the comms, and it's wired up right now, okay? It's on the same windings that the power cords were connected to. Okay, I got this one on X2 over here, okay? So that's X2, and this one's on H1. So it's, this it's on one of the 2 pins of the same winding that the power cord is hooked to, right? And this one's the same thing. So let's turn this guy on. We're going to come down here to this installation test down here. All right, guys, so I just kind of zoomed in on the meter so you can see it a little bit better, okay? Maybe we turn the backlight on too, okay? So right now it's set for 500 volts, I believe. Okay, so I just set it for 125 volts, okay? So I'm going to hit the test and we're going to see what shows up, okay? So I'm going to start off with 125 volts. Think of this like just a regular ohm meter, except for instead of, a couple of A-size batteries or even a 9-volt battery, we have 125 volts right there, okay? So let's go ahead and push that. And I'll hold it in. And we're testing 136 volts. So we're open. That's awesome. And, I could use a timer to make sure that, usually you want to hold it down for like, say, a full minute. That's like the real test. Okay, but that looked fine. So let's go to the next voltage, 250. Let's try that. Okay, it's applying the volt, 267. OL, that's awesome. So I'm feeling pretty good about this so far. You just want to hold down long enough to see if it'll break down. We're going to hold longer when we get to 1,000 if we can. Okay, 5. Uh-oh. Okay, there we go. It's just charging up, which is kind of interesting since there's low capacitance. So 527. I'm hoping this is going to be good. I'm still not too sure. Okay, we're going to jump to 1,000 volts. Okay, we have 1,000 volts here. All right, guys, let's do it. Okay, 1,029 volts. Wow, I am happy right now. This is great. I'm going to hold it down for a little while. I should have timed it right. All right, you know what? We're going to go to the other winding, and I'm not even going to go through the voltage. I'm going to start right at 1,000 volts. So I'm going to move the terminals. Hold on a sec. I'm going to turn this off just to be on the safe side. Okay. All right, guys. So I moved the terminals to X3 and H3. Okay, so we're on the other winding. I should have left one of them on the same winding just to check each winding to the other 3, right? But okay, so let's go ahead and turn this back on. I'll do that again. Okay, starts off at 500, and maybe I'll just go ahead, since it's there, I'll just go ahead and test it. Yikes. Okay, we have 400. Okay, we have 480 k ohms. I think that's what that means, because that's mega ohms. Shoot, I was hoping that we would have more. So let's go ahead and go to 1000 volts, see what happens. Uh-oh. Okay, almost a mega ohm. Okay, I'm going to just hit that one more time, just see what happens. That's interesting that it drops all the way down, then comes back up. Huh, alright. I'm going to move one of this winding to H2, so it's on the other winding, okay? And we're going to leave it on 1000. Let's just go for it. Okay, that's open. That's the way I would hope that they all would have been. All right. Okay, I put it back on H3 again. Let's try that again. Yep, same thing. We're getting about 1 mega ohm. Dang. I'm tempted to take the screens off just to see if maybe there's a thing on the screen. Well, you know what? Let me just go right to chassis, okay? I'm going to put the black one over here on chassis, and we'll check all the windings to chassis. So we check windings to windings, okay? Now let's go winding to chassis. You know what? It makes me wonder if that's why it was only wired to one winding, because they didn't trust the other one, maybe. Okay, got a 1 mega ohm to chassis. Okay. Okay, I moved that guy to the other winding. Let's try that one. Okay, that's open. So I'm wondering if it's the winding on the secondary side that has the problem. I mean, it's a mega ohm, but you know, with 1000 volts of mega ohm, I was hoping for more impedance. Okay, so I moved that one over there to the chassis. And this one over here is H3. Okay, let's try that. Wow, okay. So, it seems like one of the windings on each side might have some issues. Well, you know what? Here's the thing. If one of the windings on this side is kind of broke down a little bit to the winding on this side, then if you take either one of those windings to chassis, you're going to see the same thing, right? Because they're kind of all connected together now. Okay, let's go to the other. Yeah, so that's what it kind of looks like, because the winding that was not connected on these two sides is the one that seems like they're connected together. There's a little breakdown between them, and there's a little breakdown between them and the housing. But the other winding, the one that was wired up on each side, seems to be fine. So that makes me wonder. I wonder if there's a problem, and so they moved the power cord, but maybe it already heated up to the point where it kind of damaged the rubber, the insulation, and then after they put it all back together, that insulation cooled down, you know, over time, broke apart and all crumbled. So I'm wondering if that's what happened. Trying to be a forensic scientist here, right? So it does seem like there might be two good there might be a good winding on either side. Not sure though, right? Always makes you wonder. Alright guys, what I did is I removed the wires from H4 to chassis and X4 to chassis. So the screens are still tied to this winding. And I'm going to go, so I've got the probes hooked up to X4 and H4. So I'm going to check isolation between these two windings with that ground connection taken off and just see what we get now. Okay, I'm going to take it up to 1,000 volts. I'm just going to go straight to 1,000. All right, that's a great sign. Okay, so I've got the transformer turned around, so this side's X's, and this side's the X's, and this is the H's. But I'm going to move the probe from H4 to H2. Okay, so now we're on H2, so we're checking this winding to this one now, okay? Whoa, okay, that's great. Okay, it looks like we're open. So it looks like that winding now with the shield on it is open to both of these. So now I'm going to put I'm going to put the H4 back on the shield right here. Okay, so I got it back on the shield. All right, so now I've got the H4 back on the shield. So on that side, I'm going to take that from here and, well, here, let's just try that again. Okay, so now I'm going to take the X4 and move it to X2. Okay, let's try that. Wow, okay, what's happened now? I'm just taking the shields off the chassis, and it seems like it's made all the difference. Okay, I'm going to take the H sides over here. Okay, I'm gonna tie that little wire going from the chassis. Well, I'm going to go to the chassis on this side. Okay, on the H side, and let's go back. Now we're okay. So now we're going from chassis to X2. All right. Okay, now we're going from chassis, which over on this side is the H side, and we're going to X4 over here. Okay, that's really interesting. Just removing the chassis wires. Okay, here, let's go to the ground on this side. Okay, now on this side, I've got it on that little white wire right there, which is tied to the chassis. Okay, now we're going from the chassis to, we're going to go to these both windings, and right now we're on H4. So let's try that. All right, that's fine. Okay, now I moved it to H2. Wow, that's crazy. Now it seems like I have opens everywhere. Here, let me show you what we're doing. We're testing from either one of these two windings to this side. And both those windings should be isolated from both these two windings. So I was going from one winding to the other three and so on. And you know what? This diagram doesn't show the connection from this to chassis. And what we do, if this ends up being neutral, we're tying neutral to chassis, which we don't want, and we're doing it on both sides. So, especially on the input side, it's already tied that way at service entrance, so that's a no-no. But then also to do it on this side, we don't want to do that in our case. Sometimes you might want to do that, but when you tie them both to chassis, that's what was causing that that ohmage problem we were seeing, because I opened up one of them and opened up the one on this side, which this is the H side. So here, let's check them again, okay? All right, so the first thing we'll do is over there, I've got it tied to chassis, okay? I've got the wire going to chassis. On the H side, on this side is the H side, I've got it disconnected from chassis. So I'm going to go from chassis over here, which is right here, to both of these windings, just to show that these windings are isolated from the chassis, from the core. All right, so I went to H2, which checks this winding right here, okay? Oh, you know, let's go to 1,000 volts. I'll hold it there for a moment, and it's solid. Not breaking down insulation. Okay, I'm just going to move this over to the next one. Okay, so now I'm on H3, so I'm checking this winding, and this winding has a screen on it. Totally fine, right? All right, so now I've moved both wires to that side. So I've got the chassis connection on one, which is tied to the screen, which is tied to X4, X3. So I'm going to go to X2. All right, now if I go to the opposite side, go to X3, opposite side of the chassis connection. Okay, then we have that problem. And what it is it's going through the transformer winding. So that's what we were seeing, is the impedance of the transformer winding with that high DC voltage going to the screen. So that was what the problem was. So I'm going to disconnect both chassis connections to the windings, okay? Okay, so now I have X3 to the chassis, okay? So I've got one right on the chassis, which is that white wire, and then the other one on X3. And it's open. Okay, so I'll just go to X2, just show it's still open. It always has been. Okay. And we're open there too. All right, nice. Now let's check the two windings to, okay, those are the two windings to the chassis. Okay, so now let's check X2 to X3. Make sure these two windings are open. All right, those two windings are isolated from each other. That's great. One more time. So we got 1,028 volts there, test voltage. Okay, so that looks good. So let's go back to this other side and just verify H3 and H1, H2 is isolated from H3, H4. Okay, here we go. 1,028 volts, and it's open. All right, that's great. It looked, all four windings are isolated from chassis now, and all four windings are isolated from each other. So that's great. So it was that screen. So is that wire tying the screen terminal to chassis on both sides. It was giving us that ohmage. Now, when I went right across here, they were short, but when I went from H3 or X3, it would go through the winding, so it would give us some impedance at this HiPot. All right, guys, so sometimes you can be fine on your HiPot, but a winding from turn to turn can be shorted. I've got these wires right here. This is a 4-wire connection, so 2 of them are measurements and 2 of them are, they send the test current or voltage, okay? So we're going to check to see if the inductance is the same on all 4 windings, the inductance and the resistance. And then that will tell us if any windings from turn to turn are shorted. Okay, I'm going to go to the H side, and I'm going to the first winding, H1 to H2. All right, guys, there we are, about 48 millihenries. That sounds about right. I mean, it should be high millihenries, and 4.87 ohms. So, all right, so let me go to the other winding. Okay, there we go, almost identical, which it should be. So now let's go to the other side. All right, guys, there's one winding. And I'm holding them on because the screw terminals are too big. So that's why it's fluctuating, I think. So it's, there we go. It's like 48. There we go. Yeah, I think it looks the same as the other side. All right, I'm holding them on again. And yeah, they look pretty darn close to the same, right? So guys, these clips, it's hard to hold them on big terminals. I should put little wires on them so I can grab onto them, because if both contacts on each side isn't making equal contact, then your measurement can be off, because one sends signal, one takes measurement. So, you know, so both of these sides have to be on. Same with this one. So when I'm holding them and I'm moving around, that's why the measurement's off just a little bit. All right, guys, so what do you think? I think this transformer is starting to look like it's okay. Yeah, those wires tied to the chassis, I wonder if that caused a problem with that black wire being eaten up. Maybe the current was going through, I don't know. I'm just kind of wondering what happened. Maybe they're carrying too big of a load for these wires. I don't know what happened. This thing is pretty old. I've had it in my lab and storage for a long time. So those wires could have been heated up and they just look a lot worse now than they did at the time. But for sure they've been heated up. I think I still want to open up the cable and look inside to see how far the damage is. I wonder if it's just right at the ends. Just curious. Anyway, yeah, not sure about this. I want to do another test with power. I want to put some extra power on it and make sure everything still looks good. So I'm going to do another test, but this is kind of a precursor test, and everything's looking actually pretty good. The windings all look isolated from each other. They're all isolated from the chassis. And by the way, normally when I would do a test like this, I would just hook up all the windings together with jumpers so they're all shorted together, all the terminals, and take a wire from that and put it on one side of my HiPot and then go to chassis. So I'm chassis testing all the wires connected in parallel to chassis and seeing if that breaks down. So that'd be the normal way I'd do it. And then you take all the wires on the primary side, all the wires on the secondary side, tie them all together with, just short all the pins together, take a wire from each side, test them all at one time. So that's usually a way that's quick. It makes sure that there's no measurement errors like I had with the screen, with both of them tied to the chassis. I didn't want to go to the screen side. I knew that'd be short, but I should have thought that I'm going through the windings on each side too. So finally kind of soaked in. Anyway, so yeah, there you go. All right, guys, so thanks for watching, and 2 big thumbs up to my Patreons and my YouTube members, and Danny for being a team member. Thanks so much. You become a YouTube member, little buttons down below, or Patreon links down in the description of the video. For a little $1 a month, become a patron. Anyway, you can just help the channel, support it by subscribing, hitting the like button, doing all that kind of stuff. That really does help a lot, and appreciate it. So, okay, I think I'll do one more test, a power test, an actual power test. I've got a AC power supply that has current limit on it, so I can do it safely. And I think I'll do that before I try to put this in service. But I'm glad I found those neutral to ground connections. You know, they might have had that problem and then they disconnected the one windings, not realizing what the problem was, thinking it was a transformer, and it was really just because they're bonding that screen/neutral wire on each side to chassis. So I don't know. Yeah, it's a mystery, but I'm going to do a little more checking out before I feel totally comfortable with it. Got to put a little power on it, right? Okay. All right, thanks for watching. We'll see you next time.